Hello everyone, this is Richard from Modern Healthy Hong Kong, and welcome to our first video in a series of discussions with Professor Luigi Fontana from the University of Sydney. Professor Fontana takes a holistic view of aging, including diet, nutrition, exercise, as well as brain health and social connections. We have divided the talk into a number of topics. The first of these is diet and nutrition. What we eat is one of the key pillars in maintaining our health, and in this video, Professor Fontana talks about what constitutes a healthy, balanced diet. But first, let me introduce Professor Fontana. Professor Luigi Fontana has been studying nutrition and healthy aging in humans for the past 20 years and is considered to be one of the world-leading scientists in the field. Among other posts, he is currently a Professor of Medicine and Nutrition in the Faculty of Medicine and Health at the University of Sydney. He reveals in his new book, The Path to Longevity, that it's possible to reach 100 with the health and stamina of a 40-year-old. So Professor Fontana, welcome to Modern Healthy Hong Kong, and thank you very much for taking the time to join us today.
Thank you for having me.
Professor Fontana, you have 20 years of clinical as well as research experience in health and longevity, and you recently wrote a book, The Path to Longevity. So in this book, you focus on a number of things, but diet and exercise, as well as mental and social aspects of aging and how we can live a more healthy and fulfilling life. So for this series, I'd like to separate this into 4 topics. So diet, nutrition, so exercise, cognitive well-being, mindfulness and meditation, and then also kind of like a wrap-up with some ongoing research. So what I'd like to start with then is kind of nutrition. So how important is diet and health in delaying our longevity, or in living a healthy life? And, is it one of the major topics, the major kind of pillars?
So based on the data we have right now, probably nutrition is one of the key factors. Again, as I try to do in my book, is to look at the big picture, because, it's like, if you have a symphony orchestra and you're asking me, what is the most important instrument?
Yeah.
Many. It depends the results. If you want to have an average result, maybe if you put together the violin, the bass, and maybe few other instruments, you can have a decent result. But if you want to have a full-scale, beautiful interpretation of Mahler number 5 symphony or whatever, you need to have all the instruments in the right proportions. Unfortunately, nowadays, a lot of people, they are focusing on one or maybe 2 factors. And within that factor, there are people who are concentrating only on one factor. So right now, there is the war about, is paleo or vegan? Is keto or 5-2 diet? Is the NAD supplement or is the resveratrol? I think a lot of people, they are trying to find the magic fix to problems, but bad news. Right. You are not gonna play a beautiful symphony orchestra just because you say, I like violin. I think violin are the most important instrument in the orchestra. And so I'm just gonna concentrate on violins, and I'm gonna boost the number of violins in my orchestra. Instead of having the classical 40 violins, I'm gonna have 80 violins. So it's gonna be better. No, it doesn't work like that. So that's, unfortunately, is life, okay? And that's aging. Aging probably is the most complex biology phenomenon of, biology, of human biology, not only human biology. As you can imagine, is highly regulated. The good news is that in the last 20 years, we have discovered that aging is not like a wear and tear process, but is highly regulated. And so that's the beauty, that's the novelty. The novelty is that, we have dissected a number of pathways that are extending lifespan and health span, okay? So by using, think about, in 1930-40, just by chance, McKay made an observation that, if you restrict calories in animals by 30%, these animals were living longer, much longer and healthier. Then, a lot of scientists, Wolford and Mazzoro and Weindruch and then many other ones, they made lots of studies showing that, it was true. If you restrict calories without malnutrition, you were extending lifespan and health span. And lifespan in mice is up to 50%. It's like a human being, instead of living 80 years, would live 120, 130 years in good health. Mm. But back then, we didn't have molecular biology, and so it was just an observation. And then, we learned how to knock down genes, how to overexpress genes, and we discovered that, if you delete or overexpress genes, especially along the insulin IGF-1 mTOR pathway, this is one of the major nutrient sensing pathways, you were extending lifespan as good as calorie restriction. Mm. So that's the beauty. Now, we know of a number of pathways, that, again, the most important being the insulin IGF-1 mTOR pathway, but then, we know inflammation is important, the catecholamine pathway with the AC5 pathways, the angiotensin receptor knockout, mice live longer. And then there are another number of important pathways that are regularly aging that can be manipulated to extend lifespan and health span. Mm. Having this information, then, you can use different lifestyle factors to manipulate these pathways that we know are important for aging and for slowing down the accumulation of metabolic and molecular damage that is leading to multiple chronic diseases and eventually to premature death. So that's the beauty of the new approach, that, it's not blinded. We have understood which pathways and we know we can manipulate them. So most of my colleagues in the aging field, they are trying to manipulate them with drugs, with what is called CR mimetics. I don't believe in that. Personally, is my point of view. I don't think, that, you're going to trick such a complicated, mechanism with 1 or 2 or 3 or 4 drugs. Mm-hmm. But, the jury's out, time will tell. Right now, we know that diet and exercise and other things I said in my book, can target some specific metabolic and molecular pathways that are drastically improving metabolic health and reducing the risk of many common chronic diseases.
Right. Yes. So for humans, what would calorie restriction look like? Is it just eating fewer calories or?
Look, that's an excellent question. When I started to work in this field, like 18 years, probably 20 years now, it was 2001, and 19 years. It was May 2001 when I moved, to Washington University to start to study on calorie restriction in humans, because, I'm one of the few scientists in the world who has done studies in humans, not in animals. And one of the dogma was that the more calorie restriction, the better. When I was talking with Richard Weindruch or Edward Mazzoro, who are two of the leading experts on calorie restriction in mice and rats, the dogma was the more the better. We know that it's not true. So when you're asking what is the optimal restriction, we don't know yet. There are new studies done by several Nelson and De Cabo showing that, different strains of mice, they're responding to calorie restriction in different ways. So there are animals that on 40% calorie restriction live longer, but there are animals that on 40% calorie restriction live shorter. Then, Rafa De Cabo, he published a paper in Cell Metabolism a couple of years ago showing that if you take some of these animals and on 40% calorie restriction, they live shorter, and you impose a 20% calorie restriction, now they live much longer, because 40% calorie restriction was excessive. It was starvation.
Right.
And so unfortunately, in 2020, we do not have a biomarker that is telling us if we are overdoing calorie restriction or if our calorie restriction is too weak. So we don't have an optimal caloric intake. We don't have an optimal protein intake, because another dogma that was key 20 years ago was that the macronutrient composition of the diet was unimportant, was totally unimportant. Mm-hmm. Now we know that, the composition of the diet is as important as the caloric restriction. On the other side, I don't believe that, if you are in excessive caloric intake, even if you have the optimal macronutrient composition, you are going to live longer. So you have to have the right amount of calories and proteins and fibers and other, nutrients to have the perfect result. So going back to the analogy of the orchestra, mm-hmm. To have a beautiful symphony, probably you have been, to one of these, concerts, mm-hmm. There are in some occasion where, the conductor and the orchestra, they're able to create something fantastic. Mm-hmm. The notes are the same, because, they are playing, Bach, whatever, violin concert, but the interpretation is different because the balance between the different instruments, how the conductor is interpreting, it creates a fantastic, touching result. And so again, here is the same, to really potentiate, the health, we need the right proportion and balance of nutrients and exercise and other techniques that I describe in my book that are acting on the sympathetic, parasympathetic system by reducing stress, by reducing other factors, that we can manipulate with other interventions that are not dietary or exercise mediated. But going back to your question, diet, as far as we know, is the most important factor. Indeed, my mentor and dear friend who just died, John Holosy, many years ago, he did an experiment because back then he was convinced that exercise had an anti-aging effect. And so to prove, this, he designed an experiment. And so he randomized rats on a sedentary ad libitum lifestyle. And then he had a group of rats who were exercising. They were running on a wheelchair, and they become very lean, because he told me, they, after a while, they liked, and so they were spending few hours a day, running on the wheelchair, like for fun. And they end up, to be very lean, very low body fat, very muscular, very, very fit, with a very high VO2 max. And then he said, look, but I want to have a third control. So I want to have a control group that is weight matched with the exercising animals, but sedentary. So to do that, he had to do calorie restriction. To have the same body weight of the exercising, he had to restrict calories. So the third group were calorie restricted sedentary animals. And to have the same body weight that the exercise animals, he had to restrict calories by 30%. The results were that calorie restriction was extending both average and maximal lifespan. Exercise was extending only average lifespan, but not maximal lifespan. Technically means that exercise is improving metabolic health, but does not slow down aging. Instead of calorie restriction was improving health, but also was slowing down aging because there was an increase in maximal lifespan, meaning the last 10 percentile of the animals died much later than the last 10 percentile of the exercising and sedentary control animals. Again, strongly suggesting that exercise is an important component of health, but really is not addressing the major anti-aging pathways.
Right. So, okay, thank you. So you did talk about the composition of, as well as like calories. So could you talk a little bit about the composition? What would be the optimal composition that you would see for people of macronutrients?
Look, we don't know, but if we combine all the data we have from centenarians, from population of centenarians, the studies that have been done in mice with protein restriction by Steve Simpson and many other ones, and the methionine restriction experiments where if you restrict methionines, animals are living longer. And now there are several labs that have confirmed that methionine restriction is extending lifespan in mice, rats, and of course in Drosophila yeast. And I think that the second important nutrient. So the third is calorie. So going back to your question is how do we know if we are eating enough, if we are eating too many calories? Is waist circumference. Okay.
Yeah.
As you get older, if you are increasing your waist circumference, you are in a positive energy balance, meaning that you are eating more calories than what you need, and that's why you have an accumulation of abdominal fat. And we know without any doubt, no scientist is gonna say that that's wrong. Is an excessive accumulation of visceral fat is basically producing pro-inflammatory cytokines. We have published a paper, the highly cited paper in diabetes, showing that visceral fat is a major source of interleukin-6 and C-reactive protein, is causing insulin resistance, is causing dyslipidemia, hypertension, and many other metabolic alterations that are leading to cancer, cardiovascular disease, and dementia, and so on and so forth. So again, as I said in my book, if you have to do something, is to control your waist circumference, because you may, if you are doing exercise, especially weight-bearing exercise, you may increase body weight, but that's because you are increasing muscle mass. So the trick is to have the lower waist circumference that we can achieve. So every centimeters of waist circumference we are reducing is good, because in the abdomen, the muscle of the abdomen, are not like the muscle in the legs, in the arms. Basically they are not bulky, and so the lower the waist circumference, the better, and we have to preserve muscle mass. So that's the simple rule to check your caloric intake. Then, the protein composition, as now there is, this fad on paleo and ketogenic, so, but again, as I try to describe in my book, if we put together the data from centenarians, Okinawans, so when the Americans arrived in Okinawa in 1950s, and, Okinawa became a US military base, the doctors, they did, a survey and of the population, and they did also a food diary. So basically what the Okinawas were eating. And the Okinawas back then, they were eating around 1,800 calories a day. So they were calorie restricted, mildly calorie restricted, but they were eating only 9% proteins. 9% is basically around 50, 60 grams of protein per day, okay? So this is basically what is recommended by the guidelines. If you look the RDA for protein intake is 0.8 grams per kilogram body weight, okay? That if you do 0.8 grams per kilogram body weight is approximately 10% calories from protein. In US, on average, in Australia, in Europe, people are eating around 13% calories from protein. That basically is, 30, 40% higher than what is recommended by the guidelines. And now with these keto, a lot of people say, keto is fat, but in reality, if you look what people on a ketogenic diet eat, it's not just olive oil, avocado, and cream, but it's, salmon and chicken. And of course, they are trying to increase as much as they can fat, but in reality, you cannot live on only fat. So, the ketogenic diet is vegetable plus fat and lots of animal proteins. And again, the Okinawa was already 9%. And as you know, the Okinawans had the higher number of centenarians in the world, and the rate of cardiovascular disease, colon cancer, prostate cancer, breast cancer, lymphoma, were a fraction of the deaths, of the incidence of this cancer and the death, for this disease in US or in Europe. But it's anecdotal. But still, I'm not aware of any population on a paleo, on a hunter-gatherer lifestyle with a lot of centenarians. So back then, in US or in Australia, there were a lot of hunter-gatherers, like the Indians, think about, these tribes of Indians. They were living in a very clean environment. There was no pollution. They were exercising several hours a day on the horse and running and, hunting. But, as far as we know, none of these individuals were centenarians. Right. And instead of in Okinawa, in the same historical time, without access to modern medical treatments, there were a lot of centenarians and people were much healthier. So when people, they tell me, look, but the hunter-gatherers, they were healthy, yes, but they were not living longer. They were metabolically healthy, but they were not living longer. Then again, these data are corroborated by the animal data. When I said, if you do methionine restriction, animals are living longer. If you do protein restriction, animals are living longer. If you do a lot of experiments on cancers like we did, other people did, if you reduce protein intake, there is less cancer, less progression of cancer. And we know why. We know because basically the mTOR pathway, that is one of the most important anti-aging pathways, and we know it's important, because if you knock down mTOR or if you give rapamycin, that is a drug that is inhibiting mTOR, animals are living longer. mTOR is a sensor of energy and amino acids. So the more the amino acids, the more the energy, the more the activation of mTOR. So going back, to your question, the second nutrient apart from calories is protein. And especially the bad ones that, we are finding are the most active, the one who are activating mTOR are the brain chain amino acids and the sulfur amino acids. Okay, so these are the one who are the stronger in activating the pro-aging, pro-cancer IGF-1 mTOR pathway in animals and humans. And again, there is an entire chapter, on protein and why, and all the studies, also this myth, that you need proteins to grow muscle mass. There are beautiful randomized clinical trials done in humans that, if you don't exercise, if you don't do resistant exercise, weight-bearing exercise, you're not going to increase your muscle mass. You can eat as many proteins as you want, you're not going to increase your muscle mass. So the real important factor to increase muscle mass is resistant exercise. And the data are suggesting that, you need 30 grams of protein per meal to saturate your capacity of building new muscle with exercise. So when you eat above 60 grams of protein per day, then on an average man is around 10%, basically the excess protein get oxidized, or even worse, it stimulates mTOR pathway, and so pro-aging, pro-cancer. So that's what we know. then, you know, people, they can come up with their own idea. You know, again, you know, we are living this kind of fad, you know, religion. I'm vegan, I'm paleo, I'm here, I'm there, you know, and this is based on a distorted interpretation of data, because it depends. You know, if you look at body weight loss, if what you are measuring is body weight loss, of course, you know, you can lose body weight on a ketogenic diet. But by the way, you are losing body weight on a ketogenic diet because you are calorie restricted. So if you look at the data carefully, the people on a ketogenic diet, they are not losing their body weight because of the ketogenic diet, but because they are calorie restricted, because on a ketogenic diet, they are eating less than, you know, what they would eat on a typical American diet or Western diet. But again, you know, instead of, if you don't look body weight, but if you look longevity, then, you know, the picture is different. So it depends, you know, what is the outcome that you're measuring when you are considering the long-term effects of your intervention. And, you know, I can say that, you know, because again, you know, I started to work in this field again in 2001 as a scientist. But before, I did, you know, 5 years of residency in internal medicine, 6 years of medical school. And so basically, you know, I went through, you know, all this science, not only as a clinician and as a specialist, but then as a PhD in metabolism, and then as a scientist that I've been working for the last 30 plus years in this field. And so, you know, I've been talking, discussing with a lot of people around the world. And so, you know, and I've been doing the research myself.
Right. So before we leave protein, I had kind of one question. One thing that's been troubling me, so sarcopenia. I get older, and then, you know, my muscle is naturally going to waste. So I go down the gym, I lift weights, I'm trying to build my muscle. But to do that, I think I need to activate IGF-1 and mTOR to be able to build, and I need protein. And also, I believe that as you get older, your ability to metabolize protein kind of decreases. So do you see that there will be a requirement for older people to eat more protein as they get kind of my age or older? Or I mean, how do you combat sarcopenia?
So it's a very complicated, you know, I know what you are saying. The problem is that, you know, if you look at the data in calorie restricted animals and monkeys now, the animals on calorie restriction, they have less sarcopenia. So if you look the muscle mass loss, the slope of decline is much less in CR animals than in ad libitum fed animals. And we know from several studies that, you know, the quality of muscle mass of the animals on calorie restriction is much, much better. So I think, again, you know, this is an oversimplification of the data. I think that, of course, if you are a Roman soldier and you have to fight with a Viking that is 100 kilos heavy, probably for your survival, it is better to be bulky and to have a lot of muscle mass. But because neither me, nor you, and many other people in our society, they are Roman soldiers, you know, fighting, you know, against Vikings, you know, marching for months, you know, with heavy weights on our, I don't know why we need all this muscle mass. We need muscle mass because it's important, because, you know, as we get older, as you said, you know, I don't want to become frail. I want to be able to carry my luggage, to carry my grocery and whatever. But how much muscle? And what about the quality? It's not about a matter of quantity, it's a matter of quality of muscle mass. And so based, again, you said, you know, on experiments on mice and monkeys, the quality of muscle mass is much better in CR animals. They are eating less calories and less proteins. And the frailty, there is a paper published by Richard Weindruck, and they looked, you know, at the frailty, the capacity of the animals, of the CR monkeys, you know, to sustain, you know, all these frailty indexes are much, much, much better in the CR animals than in the ad libitum fed. So as I said, and as I wrote in my book, there are beautiful randomized clinical trials showing that, you know, when you eat 30 grams of protein per meal, you have all the proteins you need to build your muscle. All the extra, it gets oxidized and it stimulates in excess the mTOR IGF-1 pathway. So that's what I can say. That, you know, basically, I'm not saying you have to be protein malnourished.
Right.
And as I said, if you look at the RDA for protein, is 0.8 grams per kilogram body weight. What does it mean that? It means that, you know, the median for protein intake is 0.6 grams per kilogram body weight. But then, you know, because we want to cover everybody, 97.5% of the population, we increase by 2 standard deviation and we go to 0.8 grams. Meaning that, you know, half of the people, they are already in a positive nitrogen balance, because if the median is 0.6, 0.8 to cover everybody means, you know, basically half of the population is already in a positive nitrogen balance. Of course, you know, if you go then, you know, to 1.3, 1.4, 1.5, 1.7 grams per kilogram body weight, you are not only 50% higher, you are 5-6 folds higher in protein intake than what your body requires. And this 0.6 and 0.8 is calculated based on what is called the nitrogen balance. So you calculate how many proteins goes in and how many proteins go out. And you are in a nitrogen balance, in a neutral nitrogen balance, when, you know, what you are eating in terms of nitrogen is equal to what you are losing every day with your feces, hairs, and urine. You know, you are losing nitrogen.
Yeah.
So again, unless you want to become Mr. Universe, you know, as a bodybuilder, then probably you need more proteins, you know, if you want to this. But even there, you know, from experience, I have friends who were obsessed, you know, to build muscle mass. Even if they were eating huge amount of proteins, they could reach a certain amount of muscle mass growth, you know, and they were exercising like 2-3 hours in the gym, and they were eating huge amount of, you know, steaks and supplements and whey proteins. Even so, they were able to reach a certain amount. And then, you know, if they want to build more, they had to take steroids. Right. So a lot of people you see in the gym, you know, they are super bulky. It's not just because of high protein. It's because they are taking steroids. Otherwise, you're not going to grow past a certain amount of your muscle mass. So I think it's a false problem, the one, you know, you are describing. I know it's very prevalent. And, you know, the people, they are obsessed with protein. They think, you know, that if they need, the more, the better. Again, you know, it's like the more violin, the better the quality. No, I'm sorry. The more violin is not the solution to a better symphony, you know, concert. No way. You need the right amount of violins, balanced with the right amount of viola, cello, and clarinets, and flutes, and everything. It's not just because they say, I like the flute. Instead of 2, let's have 20 flutes. No, it doesn't work like that in life. I'm sorry. It's not, you know, because, you know, the steer or the wheels of your car are important. Instead of having 4, you have 20 wheels. Because that's the stupid, you know, Western approach to life. You know, having 1 brake is important. Why we don't have 20 brakes? Or having 1 wheel, 4 wheels for a car is important. Why we don't have 20 wheels? No, because, you know, you are making the car inefficient if you have 20 wheels.
One thing I'd like to talk about is timing. And so do you see intermittent fasting as important? And do you like longer term fasting? I mean, would you see like 3 to 5 days? Does that add value?
Look, you know, we don't know. The short answer to that, you know, we don't know. I think, you know, that fasting could be, as I say in my book, one of the tools, you know, we use, you know, to improve, to control calories and to maybe do some other stuff. The problem is that, you know, a lot of scientists, they believe that, you know, what happens in mice is equal to what happens in humans. They're wrong. A mice, after 2 days of fasting, dies. Most mice, after 48 hours of fasting, they die. Okay, so it's well known. And because of the high metabolic rate of mice, they can survive 2 days of fasting, depending on the strains. Some mice, 1.5, some mice 2.5. But after, let's say, after 3 days of fasting, all mice are dying of starvation. You and me, we can go for a month without eating. Okay. So meaning that, because of a different metabolic state, what we see in mice doesn't apply to humans. So it's most likely when you do 1 day of fasting in mice is like 5 or 6 days of fasting in humans. So what we have been observing in mice so far with alternate day fasting is 5 days of fasting, 5 days of feeding, 5 days of fasting, 5 days of feeding. And when we are talking about the 16-8, the time-restricted feeding, again, probably what we are looking at is basically probably like a 2-3 days fasting, 2-3 days eating, 2-3 days, because 12 hours of fasting in mice is not 12 hours of fasting in humans. So again, we have to look at this data with some intelligence and understand that mice are important animal models to generate interesting data. But, what we see in yeast, worms, flies, and mice cannot be translated directly into humans, because mice, they live 2.5 years. Humans live 80 years. Mice, after 2 days of fasting, they die. Humans, they can go easily for a month without eating. Mice, they don't develop atherosclerosis. That is the first cause of death in humans, unless you knock out the ApoE or other genes, the HDL cholesterol. The type of cancer that mice are developing are very different from the one that humans are developing. They are mainly, lymphoma and hepatomas instead of, we have carcinoma. So again, we are dealing with a completely different model. And therefore, when PhDs, they start to write books and translate, animal data into human interventions, I think, they should be very careful in what they say, what they do, because, it's not the same.
Right. Thank you all for watching. I hope that you found the video informative and actionable. Professor Fontana is one of the few scientists who has been researching aging in humans rather than in animals throughout his long career. I would like to thank him for sharing his insights in this video. In the next part, we will discuss exercise as part of a longevity protocol. Please do subscribe and hit the bell button for notifications of new videos. And please give us a thumbs up, as it encourages us to continue creating videos related to longevity. I wish you all well, and I will speak to you again soon.